Hello. Today my lecture is about the plotting of flood frequency analysis graph and the return period values, which is 2 year, after 2 year value, 3 year, 5 year, 10 year, 20 year, and then 50 year return period values. Actually, I want to plot this type of graph, which you can see. This is about the peak discharge on the y-axis and their return values on the x-axis, and basically these lines show the different colors of these lines shows the different distributions that follow the lines, and the black line is basically the fitted line the fitted line that follow the distributions. So basically I have this type of data, which is years, then their gauge reading, and then the peak discharge values, peak flow. Let's suppose the value, the date is 14 August 1989 and their peak value is 24, and similarly I have about 2010 data, which is the peak flood occurred in Pakistan. So I want to predict these flow data using R package, which is called the extreme state package. Let's start. First of all, this is my code which I have already stored here. So let's start. First of all, I will upload my data, which is here in my R lectures, flood frequency analysis, and this is Bada cohort. I import the data, which is year, gauge, and peak discharge. So the next step is to attach this data, Bada cohort. I have attached this type of data. Now I want to use a package called extreme state package. You can search, you can Google it, you will find more information about extreme state package. But here I want to install this package. If it doesn't install, so first install the package, install package, and just type extreme state, capital STAT, extreme state package, and OK. So as I have already installed this package, so I just want to library, found the extreme state package in my library, so you can see it. If you doesn't install the package, so the package will not show in your library. So the extreme state package is now uploaded. As I have already write off the code for me, so just I want to copy it. Bada cohort distl extreme, then discharge, then quite, then true. So as I have peak discharge value and OK. Then the next one is the plotting the extreme state package, which is plot the extreme. I just copy it and paste it. So what does it mean? Plot L extreme and then the data, which is name is Bada cohort. Let's suppose this is my data name. So main, then the main is the Bada river cohort return period, which you can give any name. Let's suppose I want to give it at Bada river return periods. Okay. Then the X lab, the x-axis title name, which is return period and year, y lab, which is peak discharge and feet cube per second. Then log, if you want to show your data on log, so that's true. This is the Liger's list CX.6. This is basically the contexts. I want to show my data in transparent form and best. So this can be very useful if you want to see your distributions. I want to plot all of distributions in one plot, so you can give 17 number. If you, the maximum here is 17 and number, and if you just decrease it, so you can give 10, 1, 2, 3, any type of number of distribution. When I click on it, so you can see the plot. So the peak discharge is on the y-axis and return periods on the x-axis, and these are the values, root mean square error values on this side. Now I want to create the return period values from this graph. So another code is here is the Bada cohort is basically the data name, then end return levels up to 1 and 20. So you can see on the basis of each distribution, you can see the return period values. My return 2-year return period value on the basis of Pearson type 3 is 343. The 2-year value of my return period is on the basis of Weibull distribution is 425. This is kappa distribution, gamma distribution, log normal distribution, and so on. So these are the 17 different distribution values. So the return period of after 2-year, return period after 5-year, 10-year, 20-year, and 50 years. So these are the different distribution values. Now I want to just change my distribution number. Let's suppose I just want to make it 10. Okay, so you can see the count is reduced, which is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the count is reduced to 10. And just copy this, and so you can see the distribution is reduced. Sorry, 1, 2, 3, 4, 5, 6. Okay, and now you can change it to 15. So the distribution is converted into 15 different distributions. So these this graph shows the return period values on the basis of peak discharge, that is the observed values. So on the, you can use this type of distribution on any type of data if you want to forecast your data. So you can just use the extreme state package and type here using this code, and plot this type of data. Okay, so this is all about the extreme state package, and the name of, now you can see the name of these distribution. I just check it out so that what are the names of these distributions. Okay, these are the names. Let's suppose WEI is the Weibull distribution, KAP is the Kappa distribution, PE3 is the Pearson type 3 distribution, gamma distribution, generalized normal distribution, 3 parameters log normal distribution, generalized Pareto distribution, Wakeby distribution, generalized extreme value, generalized logistic distribution, Laplace distribution, exponential, gumble, relay distribution, normal distribution, reverse gumble, and Rice distribution. So on the basis of the data, if your data is discrete data, so you can just select your type of distribution that is best fitted your data. If your data is the continuous data, so you can select any of your type of the distribution. Basically, I want to plot the return period values for the Kabul River Basin. If you want to start these type of packages, so just download the extreme stat package, Momco package, berry function package. So you need all of these packages. Then check it in library, the plot lxstream package, dest lxstream package, and use these code. So you will get the your desired plot, return period plot. These are the distributions, 17 different distributions. On the basis of these distributions, you will get your return period values. My return period values for 2 year using the exponential. This is for the Swat River. This exponential value is this. For 5 year is this. For 10 year is this. Return period for 20 year is this, and for 50 year is this. On the basis of exponential distribution. Now on the basis of gumble distribution, gamma distribution, which is this. 5 year is this, and 10 year is this value, 20 year is this value, and 50 year is this value. Similarly, these are on the basis of 17 different distributions, and their graph is this type of graph. So the Q peak value, discharge peak value is on the y-axis, and return period is on the x-axis. Similarly, this is for another river, this is for another river, and so on. Basically, there are 24 different stations I have selected for my study area, and all of the 24 stations I plotted the return period values. Now I just plot the root mean square error. If you see this graph, so you can just see here the root mean square error value is 0.0182 for Wakeby distribution, 0.0200 for log normal 3, and 0.02 for generalized distribution. So this is basically the check of your data, so your distributions. For further detail about the extreme stat package, you can just click on this GitHub link, and you will see the detail about the extreme stat package, which is here. Here is one issue that was arised by me, and the issue was resolved. If I've closed this issue was created, which is I upload the return period graph with 17 distributions. The only issue is I want the log scale on the y-axis is the code only log is equal to true, which shows log scale and x-axis, but I want log scale and the y-axis also, as the peak values of different stations are too vary. uh, I created this query on this extreme stat package, which only show the log scale on the x-axis, not on the y-axis. So uh, the this guy, decent guy, reply me, and I just created and this package, this code, and he resolved the issue. That's working, and I got both the axes with log scale. Thank you.